Okay, so let's talk about Templ. What is Templ? Why will we use it? How is it different or better than any other templating engine in Golang? Well, today we'll find out. And I also will teach you how to find Templ, because it's not that easy to find. I'm your host Ali, and this is Gotham 101. Okay, so let's get this right out of the window. To find Templ, you just simply search A-h Templ. You know, I found out if you search any other thing, you wouldn't find it as easily, because the repository that has posted the template engine actually named A-h Templ. So you'll find it easily this way. So if you just search A-h Templ, you'll find the repository, and then from there you can go to the documentation as it states here. All right, what is Templ? Templ is a way to build HTML using Go. And if you're new to Golang, and you don't have any experience or haven't written any code in Golang, well, don't worry. Consider subscribing, because I will be posting more Golang tutorials following the official Golang documentation and the Go tour to actually learn Golang and, basically get the basics. For now, I'm not going to talk about Golang. We'll talk about Templ. And I will assume that you have the basics of Golang and programming in general. And so you can follow up from here. You create components that will be rendered as a fragment of HTML and then compose them to create screening pages and documents. So basically we will write components similar to what we will write in React. For example, we also do components and then they will transfer into HTML and render. But this way is much better because it's server-side rendering. So it's not in the front end, nothing happened in the front end. The client will just receive an HTML. All the rendering and all the composing, let's call it, happens in the server side. So this is basically much faster and much more easy on the client to consume. There is a way to make it static rendering. You can create static HTML files to deploy. So there is also a way that if you want a small app or like a static app, you could do that also with Templ. It's compiled code. That means the components then will be transformed into a Go code that will be performant and fast. You can use Go syntax inside the Templ files. They say it ships with IDE auto-completion, but I found it very hard to actually make the IDE work for NeoVim because I'm using that. But if you have something like VS Code, you probably will be fine downloading and installing the extension of Templ. It will give you highlighting. It wouldn't give you auto-completion, but I don't think you need it in this file. So let's get to the installation. First thing first, you do need Golang installed in your computer. And if you don't know how to install Golang, I covered that in the first video about Gotham. You can go watch it. I'll put the link somewhere in the corner, any corner of this video. But basically, if you have Go installed and make sure that your Go is 1.20 or greater, then you can simply copy this command and go into your terminal, paste it, and then install Templ. After installation, maybe your Go that you have in your computer installed in the home directory. So you need to do a small fix to make Templ run simply from the command line. I included the path of the binary of Templ in my ZSRC file, which is the configuration file for my terminal. There I put the path for the binary of Templ. Now I can execute it from whatever I want. Okay, after installing Templ, make sure you have it, and by executing the command Templ. And then what we need to do is create our project that we will use Templ inside to demonstrate Templ and actually learn how to use it. So what we do is create a directory. Let's create a directory. Let's call it my app, right? We're gonna cd into my app. And then we need to initialize it with Go module. So what we need to do is Go mod init. We give it a name, say my app. And then the next step is to get the package Templ. So we'll just do another Go get under github.com, A-h, and then Templ, as I believe. Yes, after that, we installed Templ. Now, if we clear our terminal, then we go into any code editor you like to use. I do like to use Vim, so open up Vim, and then create the main.go file that you will use for your app. That will be the entry point of your app, basically. We create then a package main, which is our main package. We will import for now the MFT package. just to print something in the terminal to make sure that our code works. We create a main function, and then we'll use the fmt package to print a line. We'll say, for example, hello world, right? We'll save, and then we will run our code. I'm using NeoVim, so here in the command line I'm accessing the terminal. You could most definitely quit or open the terminal in your code editor. Run our code by simply saying go run, and then we give it dot to indicate in this directory. And yes, we found out that works, and we got hello world here. That basically means our code working. Next step is to create a component. So to create a Templ component, we go back to our project directory, we create a new file, we call it whatever we want. In my case, I'll call it hello.templ. Make sure you end the file with .templ. After you create the file, you then write a Go code, sort of, but then with Templ components. So what I mean by that is you define your package just like you define it in a Go file. So you say package main, because we're still in the main directory. We'll not need to import Templ because in .templ files it's already imported, so you could just use it, and we'll start using it then. We'll create a Templ component by writing the keyword Templ, and then the name of component. Of course, if you write your component in a small letter, it wouldn't be accessible by other files, so we would write it in a capital letter and would say, for example, hello, right? The way that you write a component is just similar as you write a function. Instead of using the func keyword, you would use the Templ keyword, and you open up the curly brackets. Inside the curly brackets, you need to end the curly brackets with an HTML code. Imagine it as a return. So whatever inside this curly brackets needs to return HTML so that we could render it in our web. I'm going to simply write an HTML tag here, and let's say we write an h1 tag, right? So h1 tag that would say hello. This tag will be then rendered in our page if we have, if we access this URL. After we create our Templ package, we go back to our terminal and we run the Templ generate. So the Templ that we installed, the command line Templ, we needed to generate Go code out of our Templ files. And so simply we just write Templ and then we say generate. We press enter. Now we see that we have generated code for one template with 0 errors. That means we already generated our hello.templ Go code. And to see what's that look like, in our project directory, now we have a new file called hello_templ.go. Inside this, we'll find Go code that basically breaks down the HTML and render it using Go performant code. It makes it so easier to you to write complex components and complex server-side rendering. You just write it in a Templ file, you hit Templ generate, boom, you have your Go code. You live a happy life basically, because your app is going to be fast, it's going to be accessed from tons of users, nobody will complain. After we created our Go component, what we need to do is serve it. I'm going to use the standard HTTP library. In future videos, we might use the Chi router, and we'll get to that, why would we use Chi router later, but in this video we'll just simply use the HTTP package. So let's get to it. We call the HTTP package and then we say handle func. Well, basically what handle func does, it handles any request comes to this pattern, and then it would respond with a function that will be a handler function, which we'll write by writing func. And then in my editor, I have this LSP that will autocomplete for me. So if I press enter, it will write it for me, but simply if you don't have it, it's fine. When you have a func that will take in a response writer, a W of HTTP.response writer, and it will take a request, which is R, as a pointer to the HTTP.request. So this function, it will take a response writer and a request from the request that came into this path or to this path, and then it would do, whatever you want to do with it. Now, in our case, we want to render our hello component, so we'll do just that. We'll call our hello component from the Go code. After we hit Templ generate, we have Go code exporting this component. Now we could call it hello, and we can access a function inside or from this component called render. So if we press render, this function will basically take in the R context or the context of the request like that, and then it would render it using the response writer. So in that way, we will have components rendered whenever we access the path, the home path in this case. So let's serve our app. To do that, we will basically use HTTP listen and serve to serve it locally, and we will serve it under the port 3000, because why not? If you have your port 3000, occupied or used by another application, you could use another port. And we will give it nil for the handler that we will use. Now we will use the fmt package to indicate that our server is running, basically. So we'll just simply print a message that will say listening on port 3000, for example. And then we could save and run our app using the Go run. Obviously, we get a warning of error check, so you need to error check your functions. But for this tutorial, I'm not going to do that. We're going to run our app using Go run dot. It's listening on port 3000. So let's check it out. We will access the URL for the app that we just created. And yes, indeed, we have the message hello here. And if we access or inspect the elements, we could see that in our body of the HTML, we only have this hello tag that we created with our Templ file. To make it a little bit more fun, we will render a name. We could use a variable. Instead of just rendering in our hello.templ, a simple string, we can use changeable string, or a string that we will provide from our database, or in this case from our code, and it will be rendered HTML. So to do that, we will define an argument just like we define it in a Go code. For example, we call this name, and name will be a string. Types, obviously, the Go code types. Here we say hello, and then we open up curly brackets to indicate we're going to use a variable, and we use the variable name, right? And then don't forget to hit Templ generate again to regenerate the Templ code. Go back to our Go main file, and then here our hello component should then take in a string. So we will take in a string name, let's say for example Beast Titan. My new Vim hasn't been refreshed, so it didn't update the hello component to take in a string. Now that's why it shows it as red. I could just simply quit new Vim and enter again, and obviously enter the main.go file, and now you can see that this error has gone. It basically didn't refresh yet. And now we could run the app by simply saying go run dot. After we run the app and we see it's listening on port 3000, if we refresh the page now, we should see a variable near the hello word, right? And boom, yes, we do. We have a variable. Now we say hello, and then this variable comes from our code, which means you can use this variable. I mean, you could send it from your database, you can send it from users. It's dynamic, right? It's server-side rendering. It's beautiful. It's lovely. This is basically Templ. And this video, we taken the basics. Now, if we want more and more, we will do that in another tutorials. But basically what we did is we followed these three kind of sheets documentation. And obviously if you need any more info of something not really clear, you could always refer to the official documentation under templ.guide. I hope you guys like this video, and if you do, please consider subscribing, and obviously drop a like under the video, press the like button, and stay tuned. In the future, we will get more videos about Templ, and we obviously will explore the use of HTMX and other technologies in our Gotham stack. This has been Ali, and this is More Than Coder.